So hello again. Today is the first session is Group 5, and we will have three projects presenting today, which are on-chain funding platform, privacy token, and tokenized zk finance. So again, congratulations on your work for the 3 months. It's been a long and amazing ride. Just as a reminder, 5 assigned electors will review your submissions plus these presentations and the recordings, and then they will decide until 26th January if you hit the milestone or not. So as we are ready, let's start with the first presentation, which is on-chain funding platform. If Hong Eng, yeah.
Hello everyone. I'm the representative from the Also project for our on-chain funding platform. Okay, so can I share my screen now?
Yes, of course.
So can everybody see my screen?
Yes.
Okay, so now I will start my presentation for our milestone report for all the electors as well as from the Mina team. So the outline of the presentation, first we will do a short introductions to reintroduce the problems of our project which we are trying to solve, and we'll map the problems to the products we have developed, and then we will present an overview of the results for the last 3 months, and then we will have a 15-minute of demo, and finally we'll end with some information about the next development phase of the project. So to introduce the problem that also is trying to solve, we are trying to build an on-chain funding platform for 3 actors: builders, investors, and organizers. And one of our USP, which is the reason why we build a Mina, is we enable private funding and later private voting for deciding for investor to participating in the governance projects after they invest into the project. So in this development phase, we focus on the private funding module, and we are trying to establish a funding platform and to see how it look like. Okay, so and here is a mapping of the solutions of our problems to the products we have developed. So with each actor, like builders, organizers, and investor, we have a dedicated platform like web applications for them to interact with our on-chain funding platform. And also to enable private funding, we need a threshold hormone encryption module, which is ensure that it stay correct by different set of committees. For example, also can be a committee to generate public keys for the private funding features, or if zkIgnite program runs on try to apply our platform, Mina team can become a committee to generate public keys for the encryptions of funding and voting. Okay, so that basically the information about the solutions. And here is an overview of the results that we have made for the last 3 months. Okay, so first of all, we have developed 18 zk programs, which is zk apps, and it is off-chain zk apps, but it will be utilized in our smart contracts. Most of them support recursive proof, and then we have 11 smart contracts for all of our modules, from the threshold homomorphic encryption module and the project and participation organizer module. And we have published to 3 npm package, which can be used in both the server side and the client side. And for our service, we have 4 core group of service, which are the recursive reducer service, the REST API service for the platform, the event listener service and the storage service for data availability. And we also develop 4 web applications. 2 of them are in the testing process, and 2 of them are in the integrating process, which means we are trying to work with connect with zk app and the backend. Yeah, and finally we have developed 1 brand package, which include a website, a pitch deck, and well, you see a set of logos and like the brand package for our project. Okay, so that's about the whole overview of the result. Now let me come to the let me send this link to the chat. So if someone doesn't have the election the form, you can access our result through this. And now we'll come to the demo part. So here, first of all, out of this 4 modules, so this is the core module to enable private funding. So this module has to work first for a funding campaign to be able to be created. So we will demo this application first, and then we'll visit the builder platform and organizer platform to try to create a project and create an investment campaign. Okay, so here is the DKG. I will the DKG committee app. I will reload the page. First, it will fetching cache and loading web worker. And what does this mean? This means that this is a cache for all of our smart contract and zk programs, and we run it in the web worker of the clients to avoid blocking of the normal user flow, user interaction with the website. So here you can see that first of all, we will compile all the contracts, and it will take around 2 minutes for this application because we have 11 zk programs and about 7 smart contracts to utilize in this, and we decide to compile all at the first so that people don't need to compile whenever they make transactions or interactions with the zk apps. So yeah, I can show you the code, the list of the programs. So here, so yeah, this is what we actually do in the compiling phase. Okay, we might need to wait a little bit before we can create a committee. So, and here is a list of all that committee that I have talked about. So we have the name, we have the number of keys that has been created for this committee, and we can also see the list of members with their public key. Okay, so when all the contract is successfully compiled, we can now start interacting with the smart contract. And now I will try to create a committee. Yeah, and I will add a member to this committee, which are defined by the public keys. Yeah, and I can set like some name for them to as an alias for people to understand to see who are they. In future, we can add, for example, like profilings, because these people they are responsible for the secure of the private of the privacy of user. So maybe we can add more information to let user know who are they. And here we will add a threshold. Yeah, When I submit, will we will generate all the proof required for the zk apps and then submit a transactions to the Mina Berkeley testnet. I forgot to connect my wallet. Okay, sorry about that. Yeah, we need to generate the proof again. Okay, so yes, I have sent the transaction, and now we can see the transaction in the our wallet. Yeah, yeah. And now we will need to wait for this transaction to be complete, and I can show you what is happened behind these the applications, because as you see, people when user create a committee, they can to allow them to create simultaneously concurrently that many people can use it at once. We use a dispatch reduce mechanism, which is recommended by Mina. And uh, here we have a reducer service on our server, which will wait for this action to be recognized, to be recorded on chain, and then we will fetch the necessary data, generate recursive proof, and then submit the reduced transactions from our server. So we will need to wait for about 10 minutes for this committee creation to be success. And in the meantime, I will try to create a new key from the one of the previous committee I have created. So when I create a new key here, what does it mean? This means it will create a public key that later investor can be used can use to encrypt their funding, the funding node, which specify which project they will invest to and how many they will invest to for each project. And that way, the uh, investment information can stay private from the public eyes. Yeah, for uh, the key generation process is the same as a committee. First, people will generate a key, and then we will need the server to reduce it. And then all the members from the committees need 2 rounds of contributions for the committee, for the key to be active and can be used. And after each round of contribution, the reducer service also need to run a reduce actions. And in the meantime, when we wait for the transaction to succeed and the server to reduce all the yeah, I can open it here. I will show the code to um, explain more about what we have delivered. Okay, so here an example of the committee contract and its storage API. So here,
Oh,
for example,
wait, hey, wait, we can only see your Mina scan.
okay, I'm sorry about that because I only share a window. Let me reshare my screen. Okay, share. Okay, Jose, can you see the code now?
Yes, now we see.
Yes, thank you. So here, let's take a look at the committee contract. Because like in Mina, we don't store data on the zk apps. We only store root of the Merkle trees, and that's why for each smart contract we need a storage API to define the off-chain storage that we are using. We define a way how to calculate our leaf, how to calculate the index, and here we use nested Merkle tree for optimizations and for easier to scale the off-chain storage. And in our package, in our 3 npm package, we export all these class so that, for example, our front-end applications as well as our server applications can utilize this. And if anyone's later, for example, if we open this to the public, they can implement their own versions of the apps using our package. And also to make this to make the off-chain storage available, we also provide some API for user to access the data and the witness. And in order to do this, we have implement an event and action listener service to listen to the Mina node and to build all the storage trees to make it available for the public. Yeah, you can see that. Yeah. And okay, so now let me check if the transaction is succeed. Yes. So these two transactions is already succeed, but we might need to wait a few more minutes for the transaction from the server side to be succeed. Okay, so as I say, as I described about this whole workflow to generate a new keys, you can see it will take a lot of transaction here. So in the scope of this demo, I will try to demo all the first round of contributions, and the later I will provide the demo record, and then while we're waiting, I will show you the builders and the organizers to see what are they. I will load this. Okay, so as you can see, first the web application will compile all the necessary contracts for this use case. And what is the difference between builders, organizers, and investor platform? First of all, well, let me talk about the similar part. They all have the Explorer module to see all the projects and campaigns. Project is for example, they can see information about also project or other project building on Mina here. Here is only testing data, and for campaigns, it's like investment campaigns. For example, a zkIgnite Cohort or some hackathon or some private investment cohort from a funding from a fund or from a VC or something like that. And here I can try to create my project. So in the project editor, first I can specify project name, and each project need a public key to receive money from the investment process. And now we allow user to use any kind of public key from Mina, but later in the future we may add the requirement to be a DAO contract or something like that to ensure the right of the investor in the later stages. And then the project builder, they need to specify the description of the project, the problem statement, the solutions and challenge and risks. This flow we learn from the example of the zkIgnite program itself. So you can see a lot of similar here. So yeah, for example, you can create the heading, and they can add links, and they can do other things with the descriptions, and they can add team members. Yeah, and they can add the social link here. They can also add any type of documents like a PDF or a PDF or an image. And if they save, they will save it into a draft so they can continue to edit later. And when they submit, missing input. Yeah. Yeah, it will create a transaction and submit to the blockchain. And all this information is stored in an IPFS and will be recorded on the blockchain as an IPFS hash. Yeah, as you can see, we can also see the transaction here. And for the campaign, the organizer, for example, if we want to run an investment campaign, we can create the campaign here. Oh, description, we can specify the timeline, which will be in 3 main period: the application period for project to apply into this campaign, the investment period where investor can put their money in, and then the allocation period. So yeah. Okay, I see a question, but I will try to answer it at the end of the presentation. Yeah. Currently, we only support private funding, but we might support the non-private funding in the future. Public funding. Yeah, and organizer, they can add questions here, and they can ask if this question is required or not, and they can add multiple questions. And when they submit, there is also create a transaction to the blockchain. Okay, so let me come back to see if the committee is successfully created. You not yet. Okay, but we also implement to allow the user to refresh the data without reload the website. We also do allow user to fetch it manually, because if we reload the website, all the contract need to be compiled again. So it's something we need to work on in the future for the UX experience. Okay, so I think I'm running out of time, so maybe I will end the demo stage here, and I will add more video demo later and continue with my presentation. Okay. So what will we do in the next phase of development? So first, we need to finish this phase. So as you see from our milestone, we need to finish integrating and testing of 4 zk apps, 4 web apps, and we will do a benchmarking performance and UX. For example, how long does it take for user to generate proof, and is a workflow too complex? Do we need to optimize anything? And we try to come with a public testing where user from Mina community, they can participate in and try to test our project, because we think it's the best way to see if to see where our products are at the moment. And then we will start the phase 2, where we'll define different types of investment campaigns. For example, as you see, public funding or private grants from an organizer, and we will start designing the private voting modules and DAO for our after investment phase, and a milestone based vesting mechanism as well for the funding allocation stage. Well, that's the technical part. For the here you can see the project roadmap, and we are considering to participate in the zk cohort 3 or reaching out for other angel or accelerator program. And in the business plan, why we have developed a brand package and a pitch deck, we still want to do more in this aspect. So first, we will start to engage with our community more by like introducing more about products, reaching out for other projects to see what we do together, and we want to develop our business model as well by reaching out to potential partnerships and for even angel investor to find out how to build a profitable revenue model. And as we said before, we will propose a proposal to use our platform for the next zkIgnite cohort. Yes, and I think that's the end of my my presentation, my report for this program, and yeah, and we
Awesome.
start with the QA now.
Congratulations and thank you for the great presentation. Yeah, there are a few questions in the chat if you
Yeah,
want to address them.
Yes. So do you, from IMDev, do you utilize zkIgnite for project funding management? Consider potential adding the public key and absconding with the funds. Oh yes. Yes. This is what in our plan. Right here in the on-chain funding framework. For the first phase of the project, we allow the allocation fund directly to the public keys, but later we will we will require it to be a DAO, so that investor who has funded in the investment stage, they can use the secret notes to vote for example, if the project deserves the fund or not, and how much has you done, how much has they done, and yeah, and things like that. And they can also participate in the governance of the project. How do investors receive a return on their funding? Is it in the form of token? Oh, now we support only Mina, and in the next phase we will try to support other tokens that there's a built-in token modules of Mina, and maybe later that uh, if somebody and in the community has already came up with some standards like similar like ERC20, we will try to implement that into our projects. But for the moment, it's only for Mina.
No, what I mean by that is that when an investor send Mina to the project, they have to get something back, right? So what do they get back from their investment?
You mean like the like revenues or profit, something like that?
Anything, a token or NFT or
But
anything.
you mean like a proof of investment or the or
So
in
basically,
financial?
when you have a funding platform,
Yeah.
you have a project that when, for example, will receive money
Yes.
from the investor, but the investor will get something back. So it can be like a proof, or an NFT, or even a token. That's
Yeah.
that much. So for example, if you send 10 minas, you get 10 tokens back.
Okay. So actually, we in our project we don't need that because later on, the investor they can prove that they have invested in a project by using their secret notes, which is stored by themselves. So they can prove that they know live in the Merkle tree. So yeah, we can implement a way to this is to give them an NFT or something, but it's not really necessary.
I think it is because if you a proof of something, you don't have anything, right? Because if you have a project platform of your funding platform, if you invest in someone or in something, you need to get something back from that. So a proof only is not enough.
Yes, I understand what you mean. What I mean is like technically, we doesn't need to any additional module for that to work because investor can already prove they 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 did invest without the need of any
Yes, I understand that, but
yes, I understand from the
for example, that they can have like a share of a company or a token, that's why the people fund to a project.
yes, I think it's interesting to implement that. So okay, so Jonah, can you can ask your question, right? Jonas, right? Are you raising hand?
Oh yeah, sure.
Yeah.
Yeah, thanks for the presentation. I personally do agree too that as startups most often don't pay out anything for the first years. I think it's not really required to have a token. But I have another question. If so, say I create an investment fund on this platform, and your API server goes down. How difficult would it be to use your smart contracts after that happened?
I think it's how easy. Okay, I can break down it to two parts. So first of all, it's feasible because like we have defined our storage API, like how our storage work. What is the structure of the tree of our option storage, and people can reuse us to rebuild the tree from the data from Mina node, archive node, and it's totally feasible. But to define how easy it is, that's hard to do because while yes, while our service are complex, but we do public our source code, so yeah, I think it's kind of easy to review everything because it's the idea of blockchain, right?
Yeah, if you think, yeah, that's good. If it's easy, that's good. Yeah.
Yeah. So any other question?
All right, then thank you so much again, and thanks for the questions to the
Yes.
crowd. Let's continue with the Shinki.
Okay.
Hey, hello everyone. Let me share my screen.
I see a hand, Nguyen.
Sorry, I'm just mistake
no.
pressing the button.
Wait, do you see my screen? Ah, okay.
Yes, we see it.
Okay, great. Okay, so now, so I'm going to talk about privacy coin. And so just a very quick recap, what is the idea? And this is a, zk Dev2 track project. And the idea is to actually build, or at least kind of proof of concept that we can actually build a public and privacy enabled token on Mina with the ability to interact with smart contracts. So, it's a base research and also hopefully it'll be a template and inspirational for future projects, token projects on Mina. Yeah, so I think as I kind of explained earlier, the general idea is having, like two Merkle trees, one to represent public tokens or public balances of a address, and one to represent the private one. So what was done, in this 3 months was, we experimented, and I think in the middle we kind of pivoted after deep diving into the privacy concerns. On the private side, we pivoted a bit from having a tree, to having a tree of UTXOs, and nullifiers. I'll talk about that in a while. So we kind of finished the basic milestone, basically so it's basically having the contract, it's on this GitHub So the contract, the private public balances, a full end-to-end test, a simple test contract or simple contract that we try to interact with it, and also offline REST server for tree, to query the tree nodes, and also generate witness proof. Yeah. So there was actually a Chrome extension wallet kind of milestone, advanced milestone that wasn't funded, but I started on it anyway, so I'll talk a little bit about it, right? But since the main milestone is kind of basically just codes heavy, so unfortunately there isn't much to demo, except to show you that there's end-to-end test case that you can run. So both for the main contract, so it has minting functions. You also test transfer functions from public to public balance, public to private, private to private, and private back to public. So all the test cases. I also created a very simple contract, where you trade, I think you trade Mina tokens. No, actually, this contract, basically, I think you're able to put tokens into this contract, and you can kind of useful for e-commerce. So it's just testing the interaction between this token contract and the second contract, just as a proof of concept that it works. Yeah, so I will share a little bit. This is still very much in development and not really that complete, and a lot of things not working. But I did start work, on the browser extension. They're showing kind of the privacy wallet. It has a public and private balance on these accounts, and you can send to another contract. Let me just put something here. So only some of the functions are working, so not all of it are working. So I'll just try to send, and this is going to take a long time. So I'll just leave it for now and see if it works. It's still a little bit flaky. Sometimes it's not working rightly. But okay, but anyway, yeah. So I will go on to talk a little bit about the pivot in our design. So in the original design, original proposal, we wanted to have two Merkle trees, one for public, one for private. But we realized that even though with this Merkle tree design, you do not review the public key and the balance, but even from the positions, of these balances, or seeing the patterns of two leaves within the tree being updated, right? That actually reveals certain information, or it leaks a certain amount of information about who might be transacting with who. So, and this comes from the fact that, in this kind of very typical design, a specific public key is always at a specific index within the tree, right? So if you know that person A is on index 10, person B is on index, 20, and if you see a transactions that update, two specific indexes in the tree, then you know that these two persons have transacted, even though you may not know the amount and other things, right? So that's why after a lot of experimentation and discussions, so we kind of came out with a new architecture. So the public part remains the same, whereas the private part, basically now, this is changed to UTXOs. So basically, this is there's a still public key of the owner. There's amounts, and amounts. And this is, being hashed together. But what is interesting now is that we have a third tree, which is basically a Merkle map. And this tree contains the nullifier. And what this does is that using the public key and the specific index of this UTXO, we calculate a nullifier index. And then in this index position, this is basically a flag that's either 0 or 1, right? So whenever UTXO is being used, then this index will be set to 1. So someone sending a message. Oh, okay. Yeah. Okay, sorry, this was a bit. Yeah, so that's the general idea of how it works. So basically, when we modify the private tree, to add a new UTXO is relatively simple. You just create that UTXO structure, hash it, and add it to the tree. And the UTXOs are then added sequentially on this tree. And that's the counter that keeps track of the next position to add the UTXOs. So basically, there's no, so you kind of block or you kind of hide the relationship between who is sending or who is, writing to the tree and so on. And also in the transfer function, the person who is paying the fee doesn't have to be the person who actually owns the UTXO. So in general, to have full privacy, you would have a separate account that is actually just paying for gas fees, whereas the actual identities or the actual holders of the UTXOs are completely different identities, right? And then when you want to spend a UTXO, the nullifier tree index is calculated by using this nullifier function that is based on in fact, both the private and public key and hash together with the UTXO index. And this gives you the nullifier tree index at this location. So in order to spend a UTXO, you verify that that node at that location J is actually 0, and then you set it to 1. So once it's been set to 1, this specific UTXO is then considered spent. Yeah, so in this way, basically, we have a way of ensuring that we can, spend UTXOs while not being able to, while hiding the identity. And the calculation of, one thing to understand also for those who are not familiar, the nullifier function is deterministic, right? So it means that based on what is the input, there's always a fixed output, but it requires a private key to actually calculate it. So in that sense, anybody else would not be able to actually find out what this index number is, right? So only the person who is actually spending the UTXO will be able to actually calculate, this index location, right? So that way we hide the relationship from public key to this J index. Yeah, so that's kind of, one of the major change that we happened. And then, we also built like a REST server API. So I have it running here. So basically, this server is, listening to a contract location, then it's passing all the events. And based on the events that's being emitted, it is also constructing the entire tree off-chain, right? And this is necessary because in many of the operations, you would need, sometimes you need to know what's a tree node, sometimes you need to be able to generate witnesses. So this simple server is, keeping track or reconstructing the entire tree, based off all the events. Yeah. So it does need to have a connection to both as the GraphQL endpoint and also the archival endpoint to listen for all the events. Yeah. So basically, that is what is happening. So the browser extension looks a bit like this. It's very, very basic. It's still not complete, but it's also not part of the milestone anyway. But I just talk a little bit because there isn't too much I could show from the UI point of view. Yeah, so that's what's been built. So what is the next steps for us, or is for this project? It's basically on the public tree side, right? So currently the index or the specific node of where a specific address is going to store his balance is kind of random. It's not unique, and there's no guarantee of uniqueness. So I'm still thinking that's a good way to solve this problem. And also on the privacy tree, there are still some limitations in the sense that this UTXO nouns that is used here is randomized by the sender and somehow needs to be transmitted to the recipient, right? So in the current browser wallet design, he actually have to receive these nowns through some means or text or something from the sender in order to verify its UTXO. That is obviously not very convenient. So I'm thinking there's some way where the recipient is able to decode this UTXO nouns, by himself without any other, external help or off-chain communication. Yeah. And then the final thing is also the token contract at the moment doesn't support transfer functions that are being done by the contract itself, right? So now it's only supporting external own addresses. Yeah, so this will be another limitation to overcome. Yeah, and for the wallet design, I mean, it's still very basic UI. Still using raw base 58 keys, not using seed phrases, a whole bunch of other stuff, right? But it may be, one of the few, it probably it's still a very early stage, but it's also probably the first wallet that is using O1JS directly in the browser wallet as well. So there was a lot of things I was working on just to get O1JS to even work inside the browser extension. Okay, so yeah, so that's what I have for the updates for the privacy token. So for the next, zkIgnite 3, I'm thinking of a few ideas, but probably putting out one proposal just to work on additional things. And I also hope to maybe talk more in depth about the token design, so that if there's anyone that is interested in implementing some kind of privacy token or any kind of it doesn't even have to be a token, any kind of privacy preserving data structure, right? We could, I would be very happy to share experiences, building on Mina as well. Okay, so that's that's my updates on the project.
All right, thanks for the presentation, Shingi. So there are few questions in the chat, if you can see it.
Isn't the browser extension part of the advanced scope which should be included? It's part of the advanced scope, but it wasn't funded though. So so I guess time-wise, I didn't really cater that much time to it.
Sorry, but it's the same amount, so I think it should be funded.
Same amount.
Yes, at least I see it's 7,000 for standard and 7,000 for advanced. So it's the advanced is picked.
Oh, okay. I thought that meant that it was okay. So maybe I wasn't okay. Maybe I misunderstood the thing. Okay, because I thought that that's what is on additional on top of the basic funding. Okay, at least
The amount you put in standard and advanced budget is the same. I think that's the confusion.
Okay.
So Lauri, yeah.
Okay. Yeah, no, I oh no. Okay, so I was always under the impression that it wasn't funded because it was just the same amount.
Yeah,
Okay.
I'll say it's funded as standard budget, Lauri, because they are the same. So yeah.
Okay, technical question. How is the nullify technical derived from private key? Did you use O1JS? Yes, I'm using O1JS nullifier function. So if you did create a zk app for this, if so, yeah. So I guess the quick answer to the first part for I'm deaf is that it is using the O1JS nullifier function. What methods are employed to verify this off-chain? There is no actual off-chain verification. What the off-chain component is doing is that it's receiving all of the events that emitted from the contract, and then based on the events, is reconstructing the entire tree, right? Because and where was my window? So this is a very simple view. I just printed out all the things, so you can see that this event updated a specific. So this is one group. basically it updated the index, address, and balance of inside the public tree. This is another one. So this basically this pair, right, is a sorry. This first one was a mint function. So it minted 1,000 tokens at index 0. And these 6 events that happened later was a transfer function from this address to this address. So it transferred 7 tokens from this address to this address, right? Initially it was 1,000.
I understand that, but don't you have a tree of all the nullifiers?
Do not have what again?
A tree of nullifiers.
The tree of knowledge. Oh, yes. Yeah. Nullify as well. I just didn't have it in the printouts in this specific one.
Because if you have a private coin, which means that the nullifier can only use once, right? So you need somehow to save all the nullifier in a tree.
Yeah. So
be able to
whenever
change
the nullifier, so whenever the nullifier change, it also emits an event, but it just needs the index, right? Because the content is always 1. So it will basically just be, updating nullifier tree with the index. Yeah, so with that, you can reconstruct the entire nullifier tree.
So what you mean is that your nullifier is always an index of the private key and the UTXO index. So it's not the real nullifier that you are mentioning, that we are mentioning about the creating from wallet.
Yeah, so I'm using the nullifier function to calculate the index that I'm going to change. But the actual leaf node is 1, just 1. I mean, it's just a binary thing.
Right, I understand that. But
yeah,
okay.
Because I want the tree to be, it's like a tree where you indicate whether something has been spent or not spent. Yeah, so you don't actually need to store anything else other than just 1 or 0. I mean, it's 0 by default in the entire tree. So you set it to 1 whenever a corresponding UTXO has been spent. So if you try to double spend, the contract is checking that this was 0 before it allows this UTXO to be spendable in that sense.
Yeah, that makes sense. Thank you.
Yeah. Let me see. Okay, I don't think there are other questions.
I have an extra question about
Yes.
the future. Like, is this usable like already with this project? Could I just launch a token and start using it, or what is missing?
I think I think there's still a lot. For one, I think the minting function there's no permissions, that's created around the minting function, so that definitely needs some additional work, and also to think how you want to do it. The main contract code is more or less finished. I would think that the REST API server probably needs a lot more work to be more robust. At the moment, it's just a very simple Express server, Express.js server. So there's probably a lot of functions, security, whatever that needs to be built into the API server. And the wallet needs a lot of work. So this is very far from completed. Yeah, so I just started on it not too long ago. Yeah, but I think the main token itself is more or less basically finished. So except for I think probably looking into the security aspect of the contract, getting more testing, more auditing and things like this. Yeah, but functionally it's working. Right, because it is a very complex contracts, and all the transfer functions from public to public, private to private, all 4 combinations, are all different. so that there is a lot of checking, a lot of condition checking, and so on. So yeah, I think definitely getting more security checks would be good. Okay.
All right. Thanks. Thanks, Shinky, a lot, and your hard work.
Yeah. Thank you.
Next one is Yoga. So I'm just talking to him in Discord. Normally his presentation is starting in 5 minutes, and his English, he sometimes needs help with English. He's just asking his mentor, so let's wait like for 5 minutes for him to join and see if we can bring his mentor. And again, congrats, Shinji. I think this topic is like really complicated, as you say, and these token standards and like stuff similar to ERC20 is kind of having real struggle in the ecosystem.
Yeah, it is. It took me a long time to understand the whole nullifier function and how to use it. It was yeah, but it was a very interesting journey. So
And
yeah.
do you have like, what are your next steps as a what do you plan for the?
Maybe we can discuss. I think it might be quite useful to have a session to share experiences, to even explain the nullifier function, because I read through the code to try in order to understand what it actually did, because there was like no explanation anywhere of what it's supposed to do. I just vaguely know that it is the function that I need to do what I need to do, even though no one could really explain very well how to use it. So I think that might be a kind of interesting session to do in some kind of knowledge sharing sessions.
Yeah, perfect. I think let's coordinate this, and I'll love to help you make this session happen. Also, Ivan has sent a repo.
Yeah, but that's for like a public token standard, right? So it's I guess the idea of a privacy enabled token is very, very different. Like the complexity is tremendous. Yeah. So
Ivan, do you have any feedback, or do you want to add something?
I think this is a great, I think this is a great opportunity to, like, we should just do a session on Discord on the nullifier function and invite some of the team from O1 Labs. So if someone wants to just like pick a date for that, just in the next like 2 weeks, then Yasin and I can make sure we get the right people to attend from the O1 Labs team as well.
Okay. Sounds good. Yeah, I will ping you on that.
Yeah, pick it. Yeah, just pick a date and let us know.
Yeah.
Hello.
Hi.
Hey, Cold Star.
Hello.
Hi, Cold Star.
Is
Cold
the
Star. I'm the mentor.
famous mentor? I think we are waiting for Yoga also. Yoga is joining, right?
Yes. You guys join. He pinned me just now.
Yeah, he's joining. And thanks for helping him. It's a great example of mentorship, Cold Star. I appreciate it.
Yes. Yeah. During the meeting, Yoga asked me for help to read his speech script, and he will present his PPT and the video, and I will help him read the speech script.
Thanks, Goldstar. Yoga, Yoga is also here right now.
Hello, Yasin.
Hello.
Everyone. Yeah. For tonight's presentation,
Yes,
Yoga,
you can.
come to my
You can
city.
start.
Yeah, for tonight's presentation, Yoga come to my city and he's very nervous because he don't know English very much. So he come to my house because we are in the same country, China, and the same city. So he drive to my house. Yes, for this presentation.
okay.
Okay.
Thank you for that. Okay.
Yeah, please share your PPT. Okay. Send to me, please. Okay, let me share. PPT, okay. Have you sent to me?
Okay.
Or you share?
Okay, now we see the screen. Yeah.
Okay. Okay. I will read the speech script at first person. Yeah, because they write the long page to me. And this is the zkIgnite Finance Progress Summary Report. And my name is Yoga. We are a team of 3 members. And today I am the presenter of our team. Next page. Okay, let me abstract zkIgnite Finance. zkIgnite Finance is a decentralized launchpad where you could launch your own zk token and create your own initial token share. It provides secure smart contract template with flexible configuration and complete tool suites for token management, where you could finish all operations simply in several clicks without knowledge requirement about code and zero knowledge proof. And during the 3 months, we have complete functions as below. One is Mina's native custom token creation, and we also prepare a simple wallet for users to transfer their custom zk token. The second one is the pre-sale functions. Pre-sale page functions works for project team to configure a set of pre-sale rules like sales amount, target currency, soft cap, hard cap, minimum buy, and so on. Like also vesting schedule for contributors, and also provide entry for common users to make a contribution to the pre-sale. And fair sale is a special normal pre-sale where there's no hard cap. Everyone will have the same token price after it ends. It does not matter if you buy it first or late. It means token price is equal to the result of that total raised Mina divide the total tokens for fair pre-sale. Next page. And As to private sale in tokenistic finance, it is just like a seed sale for project team to raise funds from community. There is no token at this section, but we raise funds, raise Mina as funds. And also we provide fair airdrop functions for project team to issue some tokens to the community, and people come to claim their token. The both private pre-sale, fair sale, private sale, and airdrop has the functionalities like whitelist and vesting schedule for the contributors and the project team. And also we provide some supporting pages like user participation history page and so on. We record several videos for you all to take a look. Okay, and before our next page, let's present our functionality presentation video. Just wait a moment. Yoga will show the cases. Hey, Yoga, could you share your screen, your video?
We see the screen right now.
Yes, he's trying. It seems that we cannot see your video. Just wait a moment, sorry.
I only see black screen. I don't know if you.
Yes, we are checking what's the problem. Could you
Mhm.
take a check? I'm sorry. And this is the video.
Okay.
Yeah. Can I start? And
Yes.
this is the and before the sharing, uh, we as his original schedule, we deploy tokenizkate.finance to the server, and but we meet one issue about CORS of O1JS, so he just he deploy all the back back backend systems and backend system to the server, but the UI part, he just start the UI part locally to interact with the backend system in the cloud server. Just go on. Now you can see. Now you can see this is the first page. Now we will go to create as our project team. We will go to issue our custom token. At this part, there's a brief description. In tokenisticate, that one layer one account will generate a unique unique address to a unique new address to issue the new token, which means the new address will be the token owner. Within tokenisticate, the layer one account could only generate one token. But based on one token, we could issue unlimited pre-sale, fair sale, private sale, airdrop. Just go on. Now this is the zk token creation page. At this section, we provide just one version of zk token, basic zk token. Now we go on creation. This is the total token supply. The presented text should be total token supply. And then we will go on compile the smart contract, the circuits, and calculate the witness. Just wait a moment. And then we'll trigger the wallet to issue the transaction. Now the transaction was generated. It is in the memory pool. Let's just wait a moment. Let's go faster. When the transaction is confirmed, it will forward to the creation successful page. And here people could create airdrop, create pre-sale, and the fair sale. Okay, this is the a simple page for zk token creation. Oh, there's a question, Yoga. Try to create my own token in website. Hello, Lolly. Because Yoga has not deployed the UI page to the server, so what we because of the CORS issue, so you cannot try it on tokenistic.finance currently. He promised he will deploy it tomorrow. So what we present here is the UI page is on our local machine. So this is what you see on tokenistic.finance. Yes, and then let's go on the second video, create airdrop. As you can see, we just created the zk token, and then we go on create the airdrop. Now, because under this account, we generate a new token address for token owner, and now we based on the same order only address and the unique token address. Let's go on create the airdrop. We will cost 10 Mina as the creation fee because this creation fee is used for the service maintain fee. For example, when we create a cell and user contribute the cell, and then we need our backend to maintain this cell and this token and this airdrop to monitor the on-chain event and actions to maintain some Merkle tree. So this is why we cost the creation fee. We provide a complete tour for our backend. At this part, we use some address into the whitelist, and on the web page, we will construct a Merkle tree and get the Merkle root, whitelist Merkle root. And the root as well along with all the parameters will store on chain. Let's use 3 addresses as whitelist example. The click time and click amount vesting period are the vesting schedule for the claimed user. After they claim their token, that the token will be locked for a time range. And there are several project team information, but for briefly, we just fill the local URL as example. But this is the whitelist we just filled. Now we will compile the circuit and calculate the witness. And during the wherein we will construct the Merkle tree for the whitelist. Okay, now the transaction was triggered. Yes, and now we have to wait for just a moment. Let's go faster. Okay, this is the my network breakdown. I'm sorry. Sorry, my network was breakdown. Okay, let's go on.
No worries.
Okay, finally, the transaction was confirmed on the layer 1. And then yes, the transaction was confirmed, and you could see that here you could see that when a user in whitelist and connect the wallet, then our system will prompt him that how many custom token he could claim. Go on. Yes. Is the video okay? Oh. No, it is done now. It is done now. You should重启这个. Okay, now we have created the airdrop. Now we go on create the claim the token. Share screen. 分享你的屏幕，整个窗口，整个屏幕。This is the page for user to claim their token. Go on. Let's switch to another account which is in whitelist table. Okay. Let's switch to this account which is in whitelist table. It prompts the user that he has 33 tokens to claim, and the time is okay. Well, at this section, let me explain. Because we to avoid double claim, we use nullified key to avoid double claim. And at this section, we need to deploy a zk app into the claimer's account to store the nullified key of these people. Okay, now the transaction was generated. This is for the nullified key root deployed to the claimer's account. This is really important because if there's no this section, that people will double claim. It records all the behaviors within tokenistic.finance by a nullified key and store the key root into the account. Go on. Now, the transaction for the user account was confirmed, and then we will go on the claim progress. Now we have to go on the witness calculation. At this page, I have to there's something to be noted, because as in the proposal, because the tokenistic.finance circuit is and smart contract are the size is really big, so user cannot directly claim the token at their web page. So we provide computation outsourcing service at our backend system, which means the trigger operation happens on the page, but the transaction, the witness calculation, and the circuit comparing will send back to the cloud service for the witness calculating and generating, proving the transaction, and return the transaction to the website for user to make a signature. This is how tokenistic to improve the platform performance. Go on. Okay, the transaction was confirmed. And this is the transaction. Is the video end? Okay, and this is how user claim the. Oh, hold on. I'm sorry, I dropped just now.
Hello.
Oh.
Polestar, do you have like anything to share, or are we done with the presentation? Okay. I assume we are done, or any questions?
Yeah, I think it's not optimal that we're not able to see this on chain now, that it's running locally. But same question as with the first team. What do you think? How difficult would it be to maintain the service and use the platform when your backend server is down?
Are you here to translate the question, or?
I can just write it in the chat. Maybe that helps. It can be
Yes.
translated.
Yoga, can you check the chat for question? The chat.
Oh, I'm sorry, I dropped just now.
Yeah. No worries.
Yeah.
Jonas asked the question in the chat to Yoga. If you
Could you listen the chat
Yes.
the question?
Yes, here. Do you read it?
Okay. Let me tell Yoga. Just one moment.
Sure.
Okay. Yoga answered this question that when he has two solutions for the case if the backend system was down. Firstly, the backend system, when we used some mechanism to monitor the backend system to decrease the backend system down, the server down, and this is the first step. The second step is that we decided to deploy our UI page to some decentralized storage layer like IPFS. Right. Okay. Okay. And then as you can see that as I said just now, because to improve our system performance, we forward some witness calculation to backend to cloud service for performance improvement. So if the backend system down, then we will trigger the circuit on UI page to calculate the witness on user's local explorer. So if the backend down, people could also generate the transaction.
Okay, cool. Thanks.
All right. Thanks, Coldstar and Yoga for the great presentation. And again, I really appreciate the mentorship that you have been helping to Yoga. And like really, I love Mina community because we are always welcoming to any struggle and like help each other. So Mario also says, understand the delays and this product is promising. So again, thanks all for joining. And one note, like I think Laurie asked before, Yoga will make this available, I think on chain like soon because there were some errors. So Coldstar, if you tell Yoga, if you can do it as soon as possible, and I'll share it with the electors because they will vote on the final milestone. And again, congratulations and well done, Yoga. Yeah. See you in the next session all. Bye-bye.
See you everyone.
Really appreciate you all.
Thank you, everyone.
Bye-bye.
Bye-bye.